Hello guys, welcome to part 4 of my C programming tutorial series. In the previous video, we set up our development environment. We have installed code blocks, or I have also recommended some of you guys to use online compilers if you can't access a laptop or a desktop. So if you haven't set up yet, I recommend you watching the previous video and you set up your development environment. In this video, we'll be writing our first program in C, which is the hello world program. A hello world program it's a classical program that everybody write when they first begin to start coding a language. The purpose of the program is just to print the message hello world on the screen. So here I'm in code blocks. I click new project. Now when you click new project, code blocks would give you a lot of options here. You go to files and you choose C++ source file. Now doing this is very important as it will avoid a lot of confusion later. Click go, choose the language as C, and you have to specify the file path. For the purpose of this, I have created a new folder and I'm going to name the file as hello.c. Finish. Now let me write the code first and then we'll explain it. I recommend you also follow along with me. Oops. Start by including stdio.h, followed by the main declaration, the print statement, which actually prints the message hello world, and a return 0. Now that's it for the hello world program. Just simple 5 lines of code. Now after we have done this program, hit this little gear icon which says build. This will compile our program and it will display any errors. So you can go to this build message tab and you can see it says build finished with 0 errors and 0 warnings. That means our program is successfully compiled, and now we can run this program by pressing this run button, and you can see the message hello world. That's it, we have successfully executed our first program. Now when I hit this build button and run button, we got the output. Now what is actually happening under the hood? To understand that, let me take you to the terminal. Let me erase everything and then let me start new. I'm gonna create the same file again. This is just to demonstrate that it is also possible this way, and to also explain you what is happening under the hood. Now you can see this is the same program as the one we wrote before. I'm going to save this and you can check this is the program I have written. Now if you watched my previous video, you will know that GCC is a famous compiler that we'll use. So I'm going to call the compiler from the command line GCC my input hello.c, and I want the output to be in a file called hello.out. Now this -o flag is used to specify the output file name, which I am naming it as hello.out. Now before running this, you can see there's only one file hello.c. Now when I run this command hello.c -o hello.out, you can see it doesn't display any messages, which means compilation is successful without any errors. Now when we check, we got this new file created hello.out. This hello.c is a program that we wrote in a high level language. The GCC takes this high level program and it translates it into a format that only the machine can understand, which is this hello.out. Now I can directly run this hello.out and I get the output hello world. Now if I try to read what is inside this hello.out file, it is not going to make any sense to us because it is in the format that only the machine can understand. You can hardly read something out of here. So that's how the compilation works. This GCC takes our input file and it spits out this output, which is the executable format that only the machine can understand. Now that we have successfully executed our program, now let's try to understand the program. So general structure of a C program goes like this. So every program has a preprocessor directives, which is the first few lines, followed by a main function. Every C program will have this main function and the preprocessor directives. Then inside the main function we'll have other statements, and all the statements will be terminated by a semicolon. Now let's relate this to our hello world program. This #include stdio.h is a preprocessor directive. Everything in C program that starts with a # symbol is a preprocessor directive. These preprocessor directives are nothing but messages that we give to the compiler in order to perform some task. These are tasks that we give to the compiler itself. For example, here we use the directive #include stdio.h. This stdio.h is a header file. Header files have this extension .h. STIO stands for standard input output. This header file consists of functions that we can use for standard input and output, for printing messages on the screen, for getting input from the user. All these functions are available in this header file stdio.h. There are also other header files that we can use. There is math.h, which consists of math functions like squaring, sine, cos, tan, etc. There are string functions that help in manipulating string, like counting the number of letters in a string. In a word, a string is nothing but a word, like that. So here, since we are using print functions in our program, we'll need this standard input output header file, and by telling #include, we are telling the compiler to include this contents of this file to our program so that we can use the print functions. If we don't include this, we cannot use the print functions. So that's why we tell the compiler to include this file within our program. That's where this #include comes. Now, almost every program that we'll write will start with the #include stdio.h, because in every program we'll either need to print or get input or both. Next follows the main function. Main function is the entry point of any C program. All C programs start from this main function. We have given here as int main. This int is nothing but the return type of the main function. We'll learn more about functions in a later video, but for now we have to understand that our program starts with this main function, and after the main has ended, it will return some value to the system. Here in this case we have declared this as an int. Now why we declare it is because of the standard. So generally the system gives control to a program, and the system expects result code from your program. So here we just have to return 0. A 0 indicates a successful execution. Now if for some reason our program didn't run properly and there is an error or something, so the system should know that. So for that reason this status code is used. So in our program we are just printing a message and nothing could possibly go wrong. So if we reach this point, it means our program has successfully did its job, which is to print the message. So here we are returning 0, and when we run this program, you can see the system also notifies us that process returns 0. Now if we don't return the 0, in some textbooks you will find this declared as void main. A void means we are not returning anything back, and so we didn't have to return anything here. So this also works. As you can see, this also works, but you can see this returns 12, process return 12. It is not 0. So the system would definitely think that the program has not successfully executed and there's some wrong. So it is generally a good practice to use int main and return 0 always in our program. So in any program, now take away this line, and this 4 lines would be in all the programs we write. So this is the general we can say as a skeleton for all our programs. And it doesn't really matter how we put these brackets. Some prefer to put the brackets on the next line, some put it on the same line, some put a space. It doesn't really matter how we format that, because C doesn't worry about white spaces. So you can also put it you can also give so much spaces here and it'll still work. So it doesn't really matter. So I prefer putting it on the same line and the closing bracket in a separate line. Okay, now coming back to the printf statement. This is the statement that prints message on a screen. Printf is a function that is provided by this header file, as we saw before. This printf function takes a string, formats it, and prints it. Here there's nothing to format for us. When we are printing numbers or variables, we'll need the formatting option. But here we are not doing any formatting, so we are just printing a message. So whatever we give to printf will be printed as such. And we have to know that this has to be given inside double quotation marks. So whatever we give in printf in double quotation mark will be printed as such. Now you would have noticed this weird \n symbol. So this, whatever starts with the backslash, is called an escape sequence character. An escape sequence is a special character that is used for like things that cannot be printed directly. Like here /n stands for new line, so it will print the message hello world and it will come to the next line. It is similar to pressing an enter key. Now I cannot type the enter key on this. If I press the enter key, it will move to the next line in the program. What I want is I want the enter key to be pressed on the output. So I cannot mention the enter key here with my keyboard. So that's why they have introduced this escape sequence characters. So \n here to mean it will go to the next line. Now this is not really needed. So if we run this, it's still gonna work. Nothing wrong. But there are, for some reasons, it is very important that we end the program by printing a new line. When we run the program from a terminal, for example, if we don't print a new line, the next program will start in the same line, which will make the output look very awkward. So yeah, it's better to follow these best practices. So in the next video, we'll see more about this printf statement and how we can write more efficient programs. I see you in the next video, guys. Thank you for watching.